Okay, so it says during the 12 weeks of summer, the population of tourists at a popular beach resort is modeled by the polynomial P of W, and there it is. All right, where P of W is the tourist population in thousands during week W. So W represents the number of weeks, P of W represents the population in thousands. And then it says in letter A, use the remainder theorem to help answer the following questions. Were there more tourists at the resort in week 5 or week 10? Well, the remainder theorem is basically saying that my remainder in synthetic division is equivalent to substituting that value of, in this case, this value of W into the function. All right, now I could substitute in 5 into the function and take out my calculator and do it that way and figure it out. But this is specifically saying use the remainder theorem. Okay? 1 second here. Okay, so basically what I'm going to do is I'm going to take x equals 5, right, or in this case W equals 5. And I'm going to take my coefficients here, so negative 0.1. I'm not missing any exponents up here, so this next one will be 2, and then negative 14, and then 52, and 5. And I'm going to divide this in using synthetic division again here. Right, and that's for my remainder right there. So I'm going to drop down the first term, that's negative 0.1. I'm going to multiply that by 5, that's negative 0.5. And I'll add those two together, which leaves me positive 1.5 right here. If I multiply 5 times 1.5, that gives me 7.5. And so negative 14 plus 7.5 would be negative 6.5. Now if you multiply 5 times negative 6.5, this is going to be negative 32.25. Boy, it's getting ugly here, isn't it? Let me see. Adding down the column, this is positive 19.75. And then I need to multiply 19.75 times 5. And so that's going to be 98.75. So I add 5 to that and I get 103.75. So what that tells me is that at week 5, now remember this is in thousands, so I would have to take this number here and multiply it by 1,000, which means I bump the decimal over 3 places. At week 5 there were 103,750,000 tourists. Okay, so not the easiest multiplication around, but it got us there, it got us the job done. So I know that there were a little over 103,000 tourists at week 5. So now we need to do the same thing for 10. So W equals 10, and so we're going to do same coefficients, negative 0.1, 2, negative 14, 52, and 5. All right, so here we go. This one should be a little easier with the 10. As I drop down my 0.1, I multiply that by 10, and I actually end up with negative 1. 2 and negative 1 is 1. 10 times 1 is 10, so that's negative 4. Negative 4 times 10 is negative 40. So that's 12. 10 times 12 is 120. And so I add 5 and I get 125. Now again, you got to remember that you got to multiply that by 1,000. So at week 10, there were, oops, I shouldn't put those together. There were 125 and 3 zeros, 125,000 tourists. Okay, now it says how many more tourists. Okay, so there were obviously more in week 10, and to figure out the difference, you would just take 125,000 and subtract 103,750. So I can actually do that over here off to the side. Let's see what we got. We got 125,000 minus 103,750. This is 125,000 up here. So that's going to be 21,250 more at week 10. All right? So just getting used to using the remainder theorem and answering some questions using that. The tourist population peaked between weeks 7 and 10, determined the peak week. Now, we already know what the tourist population was at week 10, so that means we need to figure out week 7, 8, and 9. Okay? Now, again, there's a couple of different ways you could do this. This remainder theorem, doing it this way, in my opinion, is going to be a lot more difficult than if we just plug in 7 to the original function. All right? So I'm thinking this time we pull out a calculator, we plug in 7, we see what the answer is. Just like in part A, I could have plugged in 5 to this function up at the top, and I would have gotten 103.75 as my answer. I could have plugged in 10, and I would have got 125 as my answer. 10 was pretty easy. 5 was not quite so easy. I'm not sure 7 is going to be that easy, so I'm going to do P of 7. So that's going to be negative 0.1 times 7 to the 4th power plus 2 times 7 to the 3rd power minus 14 times 7 to the 2nd power plus 52 times 7 plus 5. And so I'm going to pull out my calculator in a second and do that, but before I do that, I'm going to go ahead and set up my next one because I need to see what P of 8 is. Alright, so P of 8 is going to be negative 0.1 times 8 to the 4th plus 2 times 8 to the 3rd minus 14 times 8 squared plus 52 times 8 plus 5, and we'll get another number there. And then we're going to do it one more time here, and let's see here, we need some orange here, don't we? There we go. So we'll do P of 9, oops, that's red. Alright, P of 9, negative 0.1 times 9 to the 4th plus 2 times 9 to the 3rd minus 14 times 9 squared plus 52 times 9 and plus 5. Now, the nice thing about doing this is if you know how to use your graphing calculator, we can actually do this pretty quick and simple. So I'm going to open up my graphing calculator. I'm going to show you how to do this with the graphing calculator. So I'm going to go ahead and start with P of 9. All right, expand this so you can see the keystrokes here. And we're going to get rid of this. So we'll get back to the main screen here. Okay, so I need to pop all of that in. So my first one was negative, what do we have here? 0.1 times 9. We have an exponent of 4. And we need to get out of there. And then plus 2 times 9. And the exponent there is 3. We need to get out of the exponent. Minus 14 times 9, and we have an exponent of 2, and plus 52 times 9, and plus 5. Now, that takes a lot of keystrokes, I understand, but if once I get into it, okay, you can see that my answer is 140.9. So I'm going to go back for a second, and I'll come back and show you how to do this. So this would be 140, oops, 104. Let's try that again. 140.9, which is equivalent to, maybe we should put equivalent, okay, which implies 140, move the decimal 3 spots. That's once, twice, 3 times. So 140,900 tourists. Now, I really don't want to punch all that in again for 8 and 7, so I'm going to go back to my calculator here, and we're going to do 8 next, but I'm going to show you a shortcut for doing this. Now, instead of retyping that all in, if I go back and scroll up to the top and I hit enter, there we go. So it gives me the whole thing already typed out. All I have to do now is backspace. So I'm just going to go back all the way to the front. All right. It takes a while to go back here, but that's okay. And then all I'm going to do is change my 9s to 8s. Change that to an 8. So if I screwed up the first one, oops, what did I do? Back, back. That should be a parenthesis there. That should be an 8. So if I screwed up the first one and typed in something wrong, I'm going to mess up all of these. But I'm not going to know that much anyway. Change that. We've got one more here to change. Alright, so one more 8. Hit enter again, and voila, 139.4. Alright, so I know at week 8 there were 139.4. I bumped that over 3 places, and that's 139,400. Alright, so obviously week 9's winning at this point. Let's check week 7 and see what's going on there. So one more time with the calculator, I highlight the part that I want to copy. I hit enter. There it is. I'm going to go back. Alright, so there's a 7. Back some more here. Oops, too far. 7 there. More here. 7 there. And finally, here, and enter. And I saved myself a bunch of time, 128.9. Alright? So the last one is 128.9. Blue is 128.9, which implies 128,900 tourists. So week 10 we already did, so we're looking to see which week where the population peaked. So did it peak at week 7, 8, 9? We already did week 10, that was 125,000. So we can definitely see that at week 9, this is the peak. Peak at week 9. All right? Now I could have done this with the synthetic division like I did in part A, but it would have taken a lot longer, I think, to do that. All right? All right, so our next one says the volume of water in a swimming pool is given by V of x equals, and again, there's your function, not so bad this time, where V of x is the volume in cubic feet when the water is x feet high. So we're talking about volume here, so V represents volume of water in the pool in cubic feet, and x is the height of the water, okay? So it says use the remainder theorem to find the volume when x equals 3 feet. So imagine you're filling your pool up here, you know, and let's just say you've got this pool, and it looks something like this maybe, all right? And we want to know the volume of water in that pool when the height of, in the bottom of the pool might be a little curved here, but when the height of the water is 3 feet, that's what we're looking for, is right there. We want to know what the volume is. And we're going to use the remainder theorem again to do this. So when x is equal to 3, the remainder theorem here shouldn't be too bad because my first coefficient's 1, then 11, then 24, and notice I don't have a constant term, so I need to put in a 0 for the constant term this time. Here we go, drop down the 1, 3 times 1 is 3, add them up, you get 14, 3 times 14 is 42, add them up, you get 66, 3 times 66 is 18,198. Oh, and so this tells me that I have 198 cubic feet of water. Water when there is 3 feet. When, I should say maybe when the height of the water is 3 feet. The height of the water is 3 feet. Okay? And then the next question actually gives us a little different scenario here. It says if the volume, so when we say volume, we're talking about V of X up here. So when they say if the volume is 100 feet cubed, we're saying if V of X is 100 cubic feet, what is the height X? All right? So essentially what we have to do is we have to plug in 100 for V and solve for X. All right, so here we go. If I plug in 100 over here, I'm going to end up with X cubed plus 11. Wow, this is interesting. I just noticed that my variables changed up here from X's to W's. So we're going to have to fix that, aren't we? All right. Interesting, huh? All right, so 11x squared and plus 24x. And so if this is what I'm going to start with, I need to solve this. Well, in order to solve a polynomial, I need to subtract 100 on both sides. So I'll start out by doing that, minus 100. And I've got 0 equals x cubed plus 11x squared plus 24x minus 100. Okay? Wait a minute here, I gotta get something to drink. Okay, so in order for me to solve this, I've got to either be able to factor it or come up with some other way, and my guess is that's going to be by guessing and checking. Because if you look at this polynomial, if you try and factor by grouping, you're not going to make it. You know, you got a 1 out front here, then an 11, and you got a 24 and 100. It's just not going to factor by grouping. So without actually pulling out a graphing calculator, I need to pull out some P's and Q's here. So that's where I'm going to start. I'm going to start by guessing at P's and Q's, right? In this case, I really don't have to worry about the Q's, because if you remember, the negative 100 represents the P's, the leading coefficient represents the Q's, so I really don't have to worry about dividing by 1. So I need all the possible numbers that go into 100. So that's going to be plus minus 1, 2, 4 goes into 100, 5, 10, 20, then 50, then 100. Now I'm going to be a little bit smart about this in some ways. I'm not going to start off with 100, because you'll notice up here in the previous problem, when the depth of the pool was 3 feet, I had 198 cubic feet of water. So I'm guessing that it's got to be somewhere in 1 or 2, plus the fact that all the negative values here would not make sense, because you wouldn't have a depth of negative 1 or negative 2. So I'm thinking it's got to be positive 1 or positive 2. Pretty straightforward there, right? So I'm going to start off by guessing, and I'm just going to go for the small one. I'm going to hope it's 100, or 1, excuse me. I'm going to hope it's 1. So I'm going to try x equals 1, and my coefficients are 1, 11, 24, and negative 100. And this may not do it, but 1's easy. All right? And actually what I could do, if you think about this, I can do this even easier. I could plug in 1 to the function and see if I get 0. So 1 cubed would be 1. Let me do that instead. So if x is equal to 1, 1 cubed would be 1 plus 11 plus 24 minus 100. Well, that definitely doesn't equal 0, does it? So x equals 1 isn't going to work. It's got to be x equals 2. So let's try 2. So this time I will synthetically divide. So I'm pretty sure this is going to work. However, I could be wrong. We'll see. So we put out our numbers again. We drop down the first one. 2 times 1 is 2. add them up is 13. 2 times 13 is 26. 26 and 24 are 50, and look at that, 2 times 50 is 100. We have a remainder of 0. So the answer could be x equals 2 feet, but I've got this polynomial left over here. I've got x squared plus 13x plus 50 left over. And I need to know, could this possibly give me one of my answers? Maybe there's another solution that's not p over q. Maybe there's a decimal value that works here. So I need to see if I can solve this guy. So we're going to do some quadratic formula, because I don't think this thing's going to factor out here with 13 in the middle there. So we're going to do x equals negative 13 plus and minus the square root of 13 squared minus 4 times 1 leading coefficient times 50. All right, and we're going to get over 2 times 1. Now, I already know we have a problem here. Check out what happens inside the root. Negative 13 plus or minus. 13 squared is 169, and 4 times 50 is 200. So if I subtract 200, I now have a negative number inside the root. Not possible. All right, so I know that my answer has to be x equals 2 feet. All right, so volume equals 100 feet cubed when x equals 2 feet deep. All right? All right, so let's go on to the next page and see what we got going here. So we got a little bit of a scenario here. It says the graph shown below represents a company's surplus versus deficit for a 9-year period. You can see they've got the graph done from 0 to 9. Our last point actually ends up at 9.5 comma 6. All right, what is the minimum possible degree polynomial that can model this graph? So if I only look at this graph, you can see I've got 3 x-intercepts and I've got 2 curves, which could be a third degree polynomial. Third degree, because there are 3 intercepts, 3 x-intercepts, and 2 terms. Okay, if I had more terms than that, then it would have to be a higher degree, but the minimum it could be is 3 in this case. All right, how many years did the country run a deficit? What this is really asking is, where is this graph below what you would consider to be the x-axis? All right, so as I look below, you can see this point at 4 and this point at 9. Those points are on the x-axis, which means in those years there's 0 deficit, 0 surplus. The deficit, if you don't know what a deficit is, a surplus is when you have more of something, and a deficit is when you are short of something. All right, so when we're talking about money, when we're making a profit versus not making a profit. All right, so from years 4 to 9, okay, so from years 4 to 9, and if we were to write that using an interval notation, we would actually say 4 comma 9. Now, somewhere in year 4 we started the deficit, because at the intercept here at 4 comma 0, that's the beginning of year 4, and at the x-intercept here at 9, that's the beginning of year 9. So 9 we actually never touch, but somewhere in year 4 we're running a deficit, so we could use that notation to say that. The next part says construct an equation in factored form, adjusting the lead coefficient as needed. Now, I'm not going to worry about the lead coefficient. I'm just going to worry about getting my factored formula in here. So I have 3 solutions on here. I have x equals 0, I have x equals 4, and I have x equals 9. All right? So if I were to put those guys back into factored form, there's nothing I can do with the x equals 0. When you have x equals 0, that means you had a factor of x. So I'm just going to call this function f of x. All right? So one of my factors is actually x. my second factor here, to put this back in factored form, I need to subtract 4. Well, if I subtract 4, I end up with x minus 4 equal to 0. Well, x minus 4 is a factor, because normally we're doing this the other way. Normally we're taking our factors and we're setting the factors equal to 0 and solving those. Alright, so I have x minus 4, and if I subtract 9 on this guy, I've got x minus 9 equal to 0, which gives me my last factor. Now, if you were to graph those, there's a really good chance it's not going to match this graph exactly. It would have the same intercepts, but it might have a lower little hump right here, and maybe a shorter valley right here, something like that. But it definitely wouldn't match, most likely. Definitely most likely. How's that for an oxymoron? All right. So what I need to do is it says adjusting the lead coefficient. Well, right now my lead coefficient is a +1. And again, I don't know if +1 is going to work. So I might need to change that. So in order for me to change my lead coefficient, I need to put in a variable to represent that coefficient. In other words, I need to put in f of x. Normally when we see a polynomial, it's got some leading coefficient. So I'm just going to put in an a for my lead coefficient. So I'm going to call this a times x. And then x minus 4 and x minus 9. Alright? So I don't know what that a value is, but I was given one piece of information on this graph that's going to help me out. Right up here at the top, they gave me a point, 9.5 comma 6. The 9.5 represents x, and the 6 represents y, or f of x. I'm going to plug those into my function. The 6 goes in for y. I don't have anything to plug in for a, but the 9.5 goes in for x. 9.5, 9.5 minus 4, 9.5 minus 9. And now what I need to do is I need to simplify the right-hand side. Now, I'm purposefully going to do this very slow here. So this is a times 9.5. 9.5 minus 4 would be 5.5. And 9.5 minus 9 is 0.5. So I've got a times all of this stuff right here. So I'm gonna stop for a second, pull out my calculator, and I'm gonna multiply these three numbers together here, okay? All right, so if I do this, I get 26.125. I'm gonna divide both sides by 26.125. Get a by itself. So the 26.125 came from 9.5 times 5.5 times 0.5. And then I divide that out on both sides. And I actually end up with a equal to, and here's my calculation right here. We're going to go 0.229665. 0.2290.229665. So my equation now, what that means is my equation now has an a term of that decimal right there. So f of x would have to equal 0.229665 times x minus 4 and x minus 9. And that equation should yield a graph pretty close to what we're looking at right up here. So you'll notice the low point at 7 looks like it's somewhere around, I don't know, we don't really have a scale here. But if this is 6 up here, okay, we should assume that this is, -2, 4, 6, 8, 10, so this would be right around -10 or something. So here's the graph on Desmos.com. Take a look at where my minimum is. The minimum's pretty close to 7, 6.937, and we're down at -9.653. Okay? So just some nice ways to check your work when you're done to see if it even matches up and that kind of thing. All right? And now it says to use our equation to determine how large the deficit was in year 8. So according to my equation, f of 8 should equal 0.229665. And the reason I kept all those decimals is because if we round off too many of those, it's going to throw off our graph even more than it was than you saw on Desmos there. Because we were a little bit higher than what it showed in the picture above. All right, so I'm going to plug in 8 for x, so times 8, times 8 minus 4, times 8 minus 9. And literally, I can punch all of that into my calculator just like that with the parentheses and everything. I don't need to do 8 minus 4. I don't need to do 8 minus 9. So, if we do that, we end up with 7.349. So, let's go back and look at our units on our graph. So we know that 8 represents year 8. So at year 8, the deficit, okay, actually this was negative. So the deficit, that's where the negative comes from. It indicates deficit. And you can see that this would be negative because 8 minus 9 would be negative 1, which is going to make this whole thing negative. The deficit is, and I need to go back and look at my units on the graph. So it looks like, according to our picture here, that our deficit is in tens of thousands of dollars, which means now I need to move that decimal place over 4 spaces. So the deficit is 7,349, moves it over 3 times. The 0 would move it over 4 times. So the deficit is $73,490. We would not put the negative in there because the word negative is indicated by the word deficit here. All right? Done.